All right, guys, I was leading you down the wrong path here on this last problem. We are going to reapproach this one. So when we have 16x to the fourth, like I said, that's 4x squared. And now, I'm sorry, we're going to think of this because I said quadratic. This is 3 to the fourth, but 3 to the fourth is also the same as saying 3 squared. And so when you rethink of, I forgot to follow this pattern here. So when you think about this, you really have 4x squared minus 9 squared. Okay, so now it's starting to look a little bit more like quadratic. And we can actually do u substitution, but instead of letting u equal x squared, let's let it equal 4x squared, whatever that x term is. So all of a sudden, if u is 4x squared, then this is really just u squared minus 9 squared. And I wanted to show you that because you can really kind of see a little better now the difference between two squares. So we're going to have u plus 9 times u minus 9 using our special pattern for quadratics. Then we can substitute back in the actual 4x squared and see if we can factor further. 4x squared plus 9 is not factorable because it's the difference of two squares, but I mean it's the sum of two squares, which is not factorable. It's only going to give you complex roots, which you could do if you had to, but we're not going to do that today. 4x squared minus 9. So this now becomes a difference of two squares, so we can factor this again. So now we have 2x times 2x for our first term, and we have 3 times 3 for our second term. So this is going to yield 4x squared plus 9 times 2x plus 3 times 2x minus 3. Okay, that was kind of a messy problem. Let's do another. Let's look at this problem. It's not just a difference. It's going to do, we're going to have a GCF for this one. 3p to the 8th plus 15p to the 5th plus 18p squared. Okay, so factor completely. So the first thing we want to do is pull out our GCF. We see that 3 goes into all of these numbers and p squared. So we'll pull out 3p squared, which leaves us with p to the 6th plus 5p cubed plus 6. Okay, this is also a quadratic form. Okay, so if you look at this, anytime you see that the exponent starts with a 6, and then it's half that, and then it's 0, that's a quadratic, just like ax squared plus bx plus c. So this is 1 is half of 2, and remember this is c times x to the 0, and then we have a 0. So whenever our degree is like whatever number it is, and then half that, and then none, that's a quadratic pattern. And so to do our quadratic pattern, we really just kind of do the same AC factoring method that we might normally do. And we'll see that we need 1 times 6. So A is 1, C is 6. And our middle term here is 5. And so we just need two numbers that multiply to 6 but add to 5. And I'm sure you're thinking of 3 and 2. And just like we would break this up into x plus 3 and x plus 2, we are going to just do the same thing, but instead of having it be x alone, it's actually going to be x cubed or p cubed. So we're going to have 3p squared times p cubed plus 3 and p cubed plus 2. Kind of interesting. You could also do a u substitution here where you say, okay, well, I'm going to let u equal p cubed. And if you did that, this quadratic would be p squared plus 5p. And again, not p's, but u's. U is p cubed, so this would be u squared plus 5u plus 6. Okay, and so then factoring that, you would have u plus 3 and u plus 2, which would give you p cubed plus 3 and p cubed plus 2. I know this is confusing, and I know you can hear that I'm a little bit sick as I'm trying to explain it, so these two things together are not great. But I think the best thing to do is let's just do one more of these together. Let's do this problem here together. Negative 16 n to the fourth plus 625. Okay, so this is n to the fourth, and so we want to think, well, what's being squared here? Or is there a GCF? Now, the problem that we have is that this is a negative number in the front, and so this is a special situation where we're going to want to define our GCF as -1 so that we can get a positive coefficient on there. Or we could rewrite it as 625 minus 16n to the fourth, and then we see this difference of cubes. But the first thing is, is there a GCF here? Not really. We can see that this is like 4 squared, but this one is, or 2 to the fourth, really. And this one is also something to the fourth. This is 5 to the fourth. This is 5 to the fourth power. This is 2n to the fourth power. Okay, so the question is, however you want to approach this, pull out a GCF to make that positive, or change their orientation. I'm going to pull out the GCF of -1 just so you can see what that looks like. If we did that, we're going to have 16n to the fourth minus 625. And again, if we want to use the u substitution, we'll let u equal 4n squared, because 4n squared is 16n to the fourth. So we'll let u equal 4n squared. So what we'll have here now is -1 times u squared minus 625. And you have to think, well, what is the square root of 625? And I believe it is 25. So 25 squared equals 625. So we're going to have -1 times u plus 25 times u minus 25. And then we'll substitute our values back in. And we see we get one binomial that is the sum of two squares, which is not factorable. And we get another binomial, which is the difference of two squares and is further factorable. So this one is -1 times 4n squared plus 25 times, this is 2n times 2n, so 2n plus 5 times 2n minus 5. Okay, these are some examples of all these new types of factoring that build on the factoring you already know. So factoring quadratic form, you're looking for patterns, right? Something to the fourth power minus something to the fourth power. And you break that now then up into squares, and you factor it once, and then you factor again. This one, you're looking for that pattern of once you factor out your GCF, you're looking at whatever this term is this half that number? So if this was 8, this would be 4. Just like in your quadratic, it's 2, 1, 0. It would be 6, 3, 0. You're looking for these patterns. Again, a little tricky sometimes if we start out with a negative, 2 different ways to handle it. I just tend to factor out the GCF here. And by the way, we don't need to show this one. We can just show that as negative, right? That will fix it for us. Boop. And that's our negative there. Okay, so those are examples of factoring. And then in your homework, ideally, you'll be able to use some of this information to help you.